My name is Alex Williams, founder of the New Stack, and you are listening to the New Stack Analyst Podcast. Each week, we discuss our latest data research and a topic related to app development and back-end services. I want to thank our sponsors, Red Hat and SignalFX. Coming up on September 10th, you'll find us at Software Circus in Amsterdam for an event sponsored by CloudSoft and Ipsera. Then it's off to Washington, D.C. for a pancake breakfast the week of September 14th at the Spring Conference, sponsored by Pivotal. Let's get to the show. Thanks for joining us. I hope you can join us sometime for some pancakes and a podcast. Sometime soon. Okay, on to the show. Hey, Alex Williams of the New Stack here for the New Stack Analyst here at OpenStack Silicon Valley in Mountain View, California at the Computer History Museum. One of the better events I've been to this year, Boris. Nice work.
Thank you very much.
Yeah.
Thank you very much, Alex.
Yeah, and so I thought it might be helpful for me at least in helping think through where OpenStack is right now and kind of in context with some of the other movements that we're seeing. And so I thought I'd lay out my theory, and we're here with Spike. And Spike, Boris, why don't you introduce yourself first, and then Spike can introduce himself.
Yeah, okay. So I am a co-founder and chief marketing officer at Mirantis, also very hands-on with this show and OpenStack community. So I've been kind of Mirantis' face to the OpenStack community since we started, and that's me.
Mm-hmm. And I'm Spike Curtis. I'm a core developer on Project Calico, and my focus is on containers. So it's always interesting to get a more OpenStack-centric kind of view of the playing field, especially since this conference is about OpenStack, and containers has been a big theme going on here.
So clearly, containers were a main theme here, without a doubt. Okay, and so I've been trying to think through, well, why have containers been a main theme here? And part of what I think about is the developer movement that didn't start with containers, but has a precedent to it that dates back several years, and we've seen that momentum. I dated back to about circa 2006, 2007, when we started to see more REST-based APIs emerge, and the ability people think, oh, I can connect these different things.
Yep.
And so my thoughts have been about, okay, where does OpenStack fit now into that, right? And so what it seems like is the developer movement, is almost like personified in Docker. So Docker and containers are essentially a symbol, but a working actual technology that reflects the developer movement that we've seen. And then I thought, well, what about OpenStack? And so OpenStack is mostly, in my view, that underlying infrastructure. It's that hardware orchestration capability, right? Mm-hmm. And so now we're at this point where we're trying to connect the two, and that seems to be the thesis that we heard from Mr. McCluskey,
Craig McCluskey
from Google, and I heard it too from people like at Lithium who are saying, who were like talking about how solid the APIs are, right? How they're becoming more reliable, right?
Right.
And Adrian talked about lock-in, right? And he talked then about, and I asked the question. I asked you this question too on stage about this application architecture that we see emerging. So I'm looking at that and saying, what we're really seeing is this emergence of this application architecture, right? That will fit with OpenStack.
Right.
And and so I'm curious where you guys think on that, but also where you see some of the gaps and where some of the work needs to be done, and which we should see emerge, into OpenStack Tokyo and after that and beyond.
Yeah. So it's a good perspective and good question, Alex. So the way I see this is that so OpenStack has always kind of been evolving with a vision to become sort of an API standard, so to speak, for controlling elastic infrastructure. And when it first started, Nova specifically, NASA, that was exactly the problem that people set out to solve. They had a whole bunch of different infrastructure that they wanted to kind of glue together with something that is open, and that's how Nova appeared. And since then, there's been a lot of, the original kind of problem that OpenStack set out to solve was purely around VM orchestration, which is kind of an acute problem today and at the time. But since then, it's evolved into something that's much bigger, right? So it's expanded into doing orchestration for networking, orchestration for all different types of storage. Now it's also orchestrating container frameworks and things like that. I think that the vision, the premise behind what OpenStack, was originally designed to become is correct, and the approach is correct. The downside of that approach is that the solution that OpenStack is trying to kind of sets out to create involves revolving, wrapping itself around many different components. And the buckets of those different components, there isn't a standard, right? So there isn't a standard SDN right now. There's still, Docker arguably, is by far the dominant container standard, but it's, Rocket might claim otherwise. And the same goes for storage, et cetera, et cetera.
Or you can say OCI is going.
Yeah, exactly. And so there's a lot of variability, right? And I think that for the long-term vision, the way I see things evolving is that OpenStack needs to kind of preserve this vendor-agnostic, nobody's correct, there is no standard when it comes to kind of these buckets of solutions for a while, but eventually there has to emerge a standard of some sort, right? Because the idea of having 25 SDN plugins and supporting every single container standard on Earth, etc., it's good as long as there is that many standards. If there's, if Docker becomes a container standard, then everything that OpenStack does should revolve primarily around Docker. If OpenContrail becomes the SDN standard, then Neutron should wrap primarily around the OpenContrail, and etc. And I think that what's happening right now is we're very early in the market, right? So all these things like SDN containers, all these things have appeared recently. So there is no standard, there's no one solution to that. And OpenStack is gluing together all these different solutions. But going forward, it will emerge into a much more cohesive fabric. But it needs to stay completely agnostic with respect to all of these things that it touches today. So, and I think that's kind of where we're headed.
Interesting.
And in this conference in particular, what the theme is for me is actually getting OpenStack closer to all these different things that interact with it, and particularly for this year, the theme is containers, because containers have been such a hot topic in the last 12 months.
Right.
Yeah, I mean, I think that you're right that OpenStack is in a place where the fabric isn't really complete enough for us to say these are the winners and these are the losers, and therefore we should just standardize around a few or one kind of solution to different problems. And part of that is sort of that OpenStack kind of started from metal and is growing up, and the expectations of developers is sort of from code down. And so, OpenStack has, the first problem it solved was VMs and storage, and now it's starting to talk about higher level things like managing identity and things like that. And these are definitely all pieces that are necessary. But as we've kind of come down, there are places where there's a mismatch between what's coming down, like with Docker and Kubernetes, and what's growing up with OpenStack. And there's a lot of kind of weird experimentation in this area, and it's unclear kind of where we're going to end up and what's actually going to work there.
That's a good perspective. Yes.
Yeah. So I think that as OpenStack grows and matures, we need to not be afraid to kill off things that didn't fit together and don't make sense anymore. Like, you might get to a place where we're talking about VMs directly to developers, people that are writing applications, just doesn't make sense anymore. Maybe you still have VMs because that's a useful primitive for security boundaries, and so VMs are a thing that happen underneath the covers to separate when I'm making this up, but when when the primitives that you're offering developers don't make sense anymore because you have more powerful things that they can work with, then you have to sort of close off those bits of the API and not make them think about things. So like I think networking is a good example. Right now we're making people think about networking way more than they really ought to. They shouldn't have to be like, oh, well, what range of IPs do I have to have? It should just be like, I want these things to talk together, like make it happen.
Yeah, I agree. I think that's a very good kind of perspective. The way you laid it out is that like the native cloud computing stuff, container driven, that's kind of like the developer's perspective kind of going down, whereas OpenStack is a manifestation of more of a sysadmins trying to solve infrastructure problems and bringing the problems back up into the developer. And sometimes there is a match and sometimes there is a mismatch. So I think that's a very good way to look at it.
It's almost like what happen when like like times intersect, right? It's like the container story. No one knew what a container story was in 2010, right?
Right.
It was a VM story, right?
Yeah.
And so today it is a container story. How do you so you primarily see this as kind of finding that unifying that federation through set defined SDKs?
So the question is, how do you unify?
Yeah.
I think that we had a panel on that earlier, but I don't think that VMs are going away. I think that based on our customer experience, what people want is they want to have a single entry point for orchestrating physical infrastructure, and that infrastructure can manifest itself in either bare metal or VMs. And then you can place containers on bare metal or VMs, but the containers primarily is more of a it's kind of a top-down thing, right, from the developer side. So I think that these things are going to coexist. So I don't know. Does that help answer the question? I don't know.
Which gets to the complexity around networking, right? As one example of the challenges ahead. I mean, I'd be interested to hear your perspective on that. Seeing that Project Calico really is focused on it.
Yeah. So I think that the whole kind of like SDN movement and stuff like that is still pretty much in its infancy. Like when people were working with applications and networks before, you had like a sort of simple stack, from layer 2 up to layer 7, and now we've got all these virtualized networks, and so you've got like layer 2 inside layer 3 inside layer 2 again, kind of going on, and that's like a sort of manifestation of the way that people used to build applications inside the enterprise. And if you kind of leave that sort of enterprise view behind and go for a cloud first architecture, then you don't have to build these like layer 2 islands the way that people used to separate VLANs in enterprises. You can just do IP. Everyone's converging around IP as what the network technology should be, and making IP work between containers and VMs and stuff like that is not actually that hard.
Mm-hmm.
And lots of people are inventing all these crazy SDN technologies that they're trying to program the network, but the network already did what you want it to do, which is to transport IP packets from one place to another.
Right.
Like you didn't need all this extra stuff in the network, other than like some carriers basically that are trying to do SLAs for their networks where they've got these like diverse geographic things, and it's hard to run cables and stuff like that. In the data center, like it's not actually hard to just add more capacity to your network. It's not actually that hard to just move packets east to west. And so putting SDN stuff into the data center, I think, doesn't make a lot of sense, because all those extra features are not really buying you anything more up at the layer that matters, which is the applications that you're writing.
Is this one of the big gaps in your view, or is it not, or is it
gaps in what?
Well, we talked about this. this issue around networking, right? The networking, these new networking environments and how they fit with OpenStack. Is that because you mentioned SDN as a gap when I asked the question a little bit, but I wasn't sure what you were actually meaning when I asked you in one of your.
Oh, So the notion of SDN is fairly new right now, still. So one gap is in the fact that there is just a handful of SDN fabrics that scale and work, period. And when you go to a really significant scale, there's virtually nothing that works very predictably, at least in our experience. But I was meaning to ask you a question, is that there's this whole kind of notion right now between how you do networking. Some people are religious about it being pure overlay. Some people saying that overlay is a temporary thing, we'll get physical switching to the smarter, right? And others say, well, actually it's going to be a combination of both.
Right.
So what is your guys' view on which camp is going to win? And this camp's kind of battling is a manifestation of why something like OpenStack can't standardize on one thing. Let's say it was to standardize on Calico or Contrail. So they'll say it's like BGP all the way, no VLANs. That's a future. That's how we go, right? Maybe that's not the future, right? But what is your take on that?
Well, I mean, obviously with Calico, we have showed our hand. We think that providing network connectivity to the containers doesn't have to be complicated. It can be simple. It can be easy to understand and diagnose and reason about. And that, basically layer 3 is what the requirements are from applications, and so that's therefore what you should build. There's always going to be little tiny corner cases that need some sort of specialized treatment, but to build your entire infrastructure around corner cases makes things expensive and complicated. Right. And so you can build support for those little corner cases on top of the infrastructure rather than trying to design the entire infrastructure around little tiny edge cases.
Got it.
So networking is just one issue. Are there other major ones? Are there that you're thinking about, some of these questions that you have about finding ways to integrate these different in these application environments? I mean, we have things like Kubernetes, right?
Right.
We have Mesos, right?
Right.
Which has become popular in its own right.
Yeah.
Right. I'm curious. I mean, and you had a pretty interesting slide, right? Where you looked at these different environments: Kubernetes, Mesos, OpenStack.
Right.
So I'm curious. I mean, are there other gaps? Are there more gaps? Are there deeper gaps that you're thinking about? Do you think that? Let's start with that at least, and then we can get to the Mesos and the Kubernetes guys and stuff.
I think that in general, we are very early still to date in being able to realize a vision of building some sort of cohesive kind of data center wide fabric. I think that we'll get there, but I've given an example before. I think that just to put things in perspective, the cloud market that is being disrupted is, if you include the hardware component, is over $1 trillion worldwide, right? And the most successful cloud players like Amazon, they tout ridiculous revenue growth, and that is right now in single-digit billions, right? So if you go, I don't know, 3 years from now, maybe Amazon's going to be $25 billion in revenue, denting $1 trillion market, right? So this kind of gives you a perspective of how early we are in the journey. And to that effect, because we're so early, right, and we're trying to tackle so many things, OpenStack is essentially trying to integrate and work and talk to the all kinds of IT infrastructure that is like $1 trillion worth of IT infrastructure with all that diversity. To be able to kind of bring all of this diversity together into something that works cohesively, you have to solve a gazillion different problems.
Right.
And we've just kind of set out right now to solve some of them. And I think that very few of them actually have been solved in a very cohesive fashion. I think we'll see that a lot of motion going forward, kind of changing our ways of thinking and approaching how to build this thing.
What are some of the more pressing problems you're seeing right now?
Well, like I explained, like the networking, for instance, is one. just in general, like hyperscale scheduling right now. Like, so Mesos was like the first iteration at trying to solve this problem, and I think that they've done a fairly elegant job, right? But I don't think that by any stretch of imagination this problem is still solved, right?
Because Mesos is just a framework for how you can make distributed applications manage themselves. It's not a scheduler. Like, it doesn't just solve the scheduling problem. And so now we're seeing a bunch of work that people are doing, building out different schedulers. Like, I was at MesosCon last week, and Netflix just released their scheduling layer for Mesos called Fenzo, which is lets them do efficient bin packing in Amazon Web Services and things like that. So getting these distributed systems off the ground is really, really hard. And only a few organizations have been able to really nail it. And now that information and those techniques are starting to filter down into the sort of rest of the world that also has to build applications or also wants to build distributed applications. And so open source is a really interesting area right now where people are sharing these techniques and these algorithms, and we're only starting to get little islands of like, here's an interesting thing that you can do with distributed systems. This is how you can do bin packing and scheduling. And Kubernetes is like, here's an interesting thing that you can do with distributed systems. This is how you build closed feedback loops to monitor and keep your application healthy and theself-healing. And we don't really have a complete story there. We've got just some random tools which are super helpful, but there's a lot of work to do to be able to build a really complete and compelling set of tools so that mere mortals can take advantage of distributed systems.
Mesos uses Zookeeper, correct, as their scheduler?
Well, not as their scheduler. That's just
That's your resource.
It's the way that you allow coordination between the different elements in the system, so they don't trample on top of each other.
Okay. What's the Kubernetes equivalent then?
So Kubernetes equivalent of Zookeeper would be
etcd.
etcd is the data store that backs Kubernetes.
Right. And what about HashiCorp? What is their...
Theirs is called Consul.
Consul, right.
And Consul is basically like take a distributed data store and then build some purpose-built service discovery power on top of that and roll it all in one package. So like service discovery is another one that's hard to do in distributed systems, and we've got a couple of different tools. So Consul's one, and Mesos DNS is another, and Sky DNS that Kubernetes uses is another.
So how does that affect OpenStack? Because all these schedulers are still very much in their infancy, and
OpenStack apparently is just gonna do them all. Like you were talking earlier, like we just kind of have to be agnostic.
Exactly correct. I think that when it comes to scheduling, there's scheduling is very specific to what it is that you're scheduling, right? So, and like Kubernetes, schedules containers in a particular way and creates some primitives to be able to do it. Other frameworks schedule containers in different ways. So, like Mesos, for instance, is it's a fairly agnostic scheduler in the sense that the whole idea there is that it can see a whole hyperscale pool of infrastructure, and it can make resource offers to the second layer scheduler, such as the Kubernetes scheduler. So it on one hand understands that I have Hadoop running, I have Kubernetes running, and I have a whole bunch of other things that require scheduling running on top of me. Right? They're all complicated schedulers, their own kind of scheduling frameworks. I understand these frameworks, I understand resources underneath, and I can optimally match the two. Right? So that's very relevant when you're having many distributed systems with different scheduling primitives and different scheduling algorithms running across a single pool of very hyperscale distributed infrastructure. So it's like a meta approach to scheduling. And ultimately, I think that it really depends on the use case of where you deploy and what you're deploying. So OpenStack's approach to scheduling so far has actually been, OpenStack's really been good at scheduling virtual machines. It's been doing okay job at scheduling virtual machines, but now the model there is evolving into more of a kind of a pluggable scheduler model. So you can embrace different primitives and different kind of scheduling paradigms. So I don't know which one is going to be the winning scenario.
That's where we are right now. We're trying to understand all those paradigms.
I think this is actually a decent example of where there's this kind of mismatch of what's going on. Because like the strength of Mesos is to be able to look across an entire giant pool of resources and schedule workloads that need different things. So big long-running jobs, things that respond to spikes in demand versus like batch kind of things. And so OpenStack's approach so far as their experiment has been to like take Mesos and put it into a little box.
No, that's
inside a bay, rather than like having some sort of thing that can actually understand the entire data center and multiple tenants and things like that. And that's just, you know, the reality of the technology that we have now. Mesos is not very good at keeping tenants who might be hostile to one another from like trampling on each other or eating up all the resources. So like the pragmatic thing to do is say, look, you know, you can just spin up a Mesos and that's just yours, and somebody else will spin up a Mesos and that's just theirs. But if we really want to get to super high utilization across the entire data center, the entire pool of resources, that's not going to work long term.
Yeah, no, I mean the approach from like the way it's done right now, in my opinion, is that Mesos should be kind of the first layer, right, of OpenStack running as a second level framework on top of Mesos. So you can have Kubernetes running alongside OpenStack, alongside something else, with Mesos fabric being underneath. At least that's the idea of Mesos, as I understand. If you take Mesos and just shove it in to to a limited number of VMs or whatever resources exposed to it by OpenStack, that just that's people getting it backwards.
So that's
but I think that the OpenStack community understands how it works, right?
Mm-hmm.
So the good thing about the OpenStack community is that they most of the people there, and this goes to my presentation, they don't suffer from not invented here syndrome, right?
Mm-hmm.
And they're very open to using things for the purpose that they were built, right? So there's no kind of this notion in OpenStack today, oh, let's throw away OpenStack VM scheduler, use Mesos to schedule VMs, or God forbid, let's use OpenStack resources and expose those resources to Mesos so Mesos can schedule stuff on top. That's just kind of silly.
Mm-hmm.
I think that people understand that Mesos is a kind of good lower level solution for OpenStack to run on top of as a framework, and how do we enable kind of the problems that we have solved in our OpenStack ecosystem story, work on top of that is the way people approach it.
Mm-hmm.
At least that's the way we approach it in Mirantis. So,
well, that provides some distinction between Kubernetes and Mesos. So that seems to be a real source of confusion, even with with smart technologists. Are there other distinctions we need to think about? I mean, with Kubernetes and Mesos, because we hear so much about Kubernetes, right? In the context of OpenStack, we don't hear as much about Mesos.
I think that you hear a lot about Kubernetes, partially just because of the people that built it. Like, we all know that Google got their hands dirty and have been doing containers at giant scale for a while, and they've said, like, we took our lessons learned and then designed Kubernetes, and that makes people stand up and say, oh, okay.
Yeah.
And Mesos came more out of academia, and like Twitter jumped on it, and they also have some cred, but they don't have Google cred in terms of running services at scale.
Do you remember when they panicked? They realized that Ruby didn't scale. Do you remember that? And then that's really kind of where it seems like things originate.
Yeah, but the reality of it is that from what I know, actually, the kind of the mega scheduler, the what is it called, like Omega or something like that Google uses underneath, is much closer to what Mesos is than what Kubernetes is. And the problem is that like Mesos is really cool, but it's only relevant at hyperscale, and there's very few people that do the scale at which Mesos is relevant. So what Kubernetes does, it operates in kind of cluster primitives. So you have like a few clusters that you don't need Mesos there. Kubernetes will just own these clusters and do the job. If you have 10 data centers, then you'd want to layer something like Mesos on top, and then run Kubernetes clusters on top of that, right? So it's kind of where the world is today. Kubernetes is probably more relevant to the consumption model of containers than Mesos is, because Mesos solved like a mega problem, right? Mm-hmm. Kubernetes solved a specific problem that in many cases you don't just need Mesos underneath. Mm-hmm. That's how I see it.
Mm-hmm. And I think that part of the reason that's true is because neither of those really have a good story for how how you do multi-tenant stuff, where you've got different people who want these resources and kind of keep them from trampling on one another. So you have to kind of so like Kubernetes is a thing that you can just sort of spin up, and to a certain extent so is Mesos. So you want to have some way to be able to actually schedule some organization that's not even that big. Like some of these enterprises are not that big. They're not Google big in terms of the services, but once you get everybody in that organization who has every single app, that's a scale where Mesos makes sense, but you don't have the tools to actually segregate out resources to the different groups. How much does accounting get? How much does marketing get? And so when we can build those tools and on top of Mesos, then it will make sense for even relatively small organizations to run something more like Mesos, even if it's not Mesos.
Well, great. Well, Boris, thanks for having a terrific event here, and interesting times for OpenStack. I look forward to Tokyo and see where these conversations are. When I was in Paris, we did a little mini event in the evening, and we talked about containers. It was just kind of barely formulating, but that was not very long ago.
Yeah.
So.
Yeah, a couple of years from now, we'll be talking about something else.
Yeah, for sure.
That's just how it works.
That's the fun of it.
So, yeah.
Great. All right. Thank you, guys.
Thank you.
That's it for this week's show. Thank you very much for joining us. Audio editing and sound design for the New Stack Analyst podcast is provided by Broken Hours. You can find them at brokenhours.com. Thanks again. I hope to see you back at the show. Bye-bye.